Hi, everyone, and welcome to another episode of Pathfinder, a podcast by Payload, the leading digital media company in the space industry. I'm your host, Mo Islam, and this week we have Colin Doughan in the hot seat. He's the CEO and founder of Gravitics, a startup based out of Seattle, Washington, building space station modules, which will eventually have artificial gravity capabilities. Colin is a second-time founder, having previously exited a business to Voyager. We have a lot to cover today, from the origins of the company to an Elysium-like vision of the future. So let's get started.
This week's episode is brought to you by Epsilon 3, software for complex engineering, testing, and operational procedures. Epsilon 3's web-based procedure platform enables technicians, operators, engineers, and management to instantly access information around current status of operations, release history, and historical reference of procedural content. Epsilon 3's platform is better suited for coordinating space development workflows than word processing software, Microsoft Excel spreadsheets, and other applications that are not tailored for the industry. For more information, check out epsilon3.io.
Colin, it's great to see you again. How are you?
Good. Thanks, Mo, for having us.
Yeah, welcome to the show. Now, I know that a lot of our listenership is typically listening to the show and not watching it, but you have a very interesting background behind you. So tell us a little bit about what we're looking at.
Yeah, absolutely. So Gravitics builds large real estate platforms for space. And you're seeing some of that examples of those prototypes behind us. So one of our 8-meter decked out prototypes, if you wanted a large open space, and then one of the welding prototypes behind me to my left. So we are hardware rich and we build very quickly, and we want people to be able to come and touch and feel, and that includes our engineers as well.
And where are you guys? Where is this facility based?
Yeah, so Gravitics is just north of Seattle in a town called Marysville here in the Pacific Northwest.
Okay, great. Well, before we jump right into the story of Gravitics, tell us a little bit about you. Where did you grow up? How did you get into this? I always, look, most entrepreneurs in space are crazy. But there's a level of craziness. There's like, okay, well, I want to build a satellite to, hey, I want to build space stations. So I always love to see like, okay, how did someone get to this point? So, you're building space station modules. So tell us a little bit about how you got here.
Sure. My mother says that at 6 years old, I told her I wanted to work for an astronaut company. So I guess I had the head shaved and drank the Kool-Aid from a very young age. 20 years at Lockheed Martin. Worked nuclear programs, helped modernize the launch range in Vandenberg. For the last dozen years, was working large aerospace constellations for U.S. Air Force, U.S. Space Force. One of the few entrepreneurs in this sector that already has an exit. So co-founded Altius Space Machines and sold that was Voyager's first acquisition back in 2019. And my wife was kind enough to let me go do it again. So started looking for what the industry needed next, and really saw that it needed a real estate provider as we retired the ISS. And so Gravitics was born. Well,
tell us a little bit about the business you started first, because it sounds like you've significantly up-leveled the ambition on this one.
Very true. Absolutely. So Altius builds, I think we've got maybe 500 assets in orbit, supporting the OneWeb fleet and a variety of other products. So lots of satellite servicing support infrastructure, and very much more than garage, but on a much smaller scale. And so if Lockheed would be on the large end and my first startup on the small end, Gravitics is aspirationally somewhere in between.
Got it. So the easy question to ask at this point is, why start a space station business? Now I know, and we can talk a little bit about the model, because you're not quite operating the businesses, but tell us a little bit about what led you to want to solve this problem.
It's kind of down to dominoes. What were some of those early dominoes that if we got them knocked down, the rest would fall? And by that, I mean, the rest of the industry would develop, and we would have kind of that humanity, extending, flourishing all the way through the solar system is kind of Gravitics' goal. Looking at what humanity needed, whether it was going to be humans in this real estate, in these modules in space, or whether it was going to be robotics, real estate and power, two of our early product lines, are going to be key needs. And so providing those for the industry at low cost, leveraging many of the industrial processes that have been so successful here on Earth. Felt like a key area that we could speak into with launch close to being solved. What's kind of that next thing that needs to be solved in order for us to kind of push out into the cosmos? Having clear spaces to be able to operate inside of is going to be important.
So when you first started Gravitics, was there sort of an initial vision for the business that's evolved, or has it always been the same sort of long-term goal?
I think maybe the part that's evolved has been the surprise of how many people have raised their hand to say, hey, could you for us as well? And, we started saying, okay, with a name like Gravitics, we believe long-term, some form of spinning gravity is going to be absolutely critical to keep us from, right now we're in, canoes circling the island, and that's great. Good place to start. Eventually you have to go out into the big dark. And to be able to do that, we're going to need to not only be able to take our spaces with us, but we're going to have to take our gravity with us as well. And the good news is that a lot of the studies on the ISS have resulted in some powerful understandings that lunar gravity could be that sweet spot for maybe 80% of the ills that ISS astronauts have encountered over the years. But that still requires a certain amount of spin gravity. The market today is ready for zero G. We need to develop that app store, if you will, and fill it with all of the different use cases that can benefit from zero G. But from there, especially if we are going to move beyond low Earth orbit, we're going to have to take that gravity with us. So our modules are designed today for zero G, but compatible with a spun future that we see happening over the next decades.
Well, just to kind of tap on that for a second, and we'll talk. We'll get deeper on the technology in a little bit. But you said that the modules are, you said, designed for zero G.
Yeah. So the way to think about our modules are going to be, obviously, the pressure hull is going to be incredibly important, and then all the smarts that go on the inside. So they have propulsion. They're able to, when they leave the launch vehicle, be able to basically then self-deliver over to the space stations and then help those space stations scale as they're ready to in a cost-effective manner. So we have all of that capability on board.
So what's the sort of business model today for the business? Like, how are you guys planning to generate revenue? I know there's a contract news that we'll talk about that you guys announced a couple weeks ago, but yeah, tell us a little bit about the business model.
We are a space infrastructure provider. We provide largely across three verticals. There's going to be needs in real estate, so we will help space stations expand one module at a time. There's going to be needs around logistics, and we can provide services where we fill our modules with needed cargo, et cetera, and deliver those to stations. And then long term, there's going to be an extended utility needs, and power is going to be one of those key ones. And we hope to be able to play in that space as well with some of our new battery technologies that are coming online.
Is there a reason why, in my perspective, is building the space station is the hardest part, right? Maybe, and this is your chance to correct me for sure.
Right.
But building these modules, putting them up in space, that's hard. That feels like really, that's the challenge. Once you're up there, why sell that? Why not just operate it yourself? Why not build the market yourself?
I think the challenge comes down to, maybe I would challenge whether it's hard. It's just different hard, right? Owning those customers, owning those relationships, finding profitable uses for each and every hour of astronaut time. That's its own version of challenging. And we definitely want to be able to support our customers in that. But a compelling reason to use Gravitics rather than provide this in-house is you build a space station once. And sure, you've got some scaling needs along the way, and we hope to help these customers continue to grow. But you have a large build-out, a large CapEx expense at the beginning of this build-out window. And then perhaps a slower, gentler ramp after that. Do you really want to invest all the equipment necessary to maintain this factory to be able to build space stations when you only do that build out once? If I can provide this for the industry, I'm able to give you a better price per space station per module than you'd otherwise be able to do. And I also help you avoid a massive amount of cost you otherwise would have to have just for your own modules, where I can amortize that over an industry.
So let's take a step back. We've had Axiom on the show. We've had Vast on the show. We've had Sierra on the show. We've had a number of the future operators of space stations on the show, but most recently had Vast. And there's a few questions that I asked Max and Jed that I'd love to get your perspective on, because it may not be a directly related to your business, but your perspectives on it are really important, right? Because they ultimately drive the future of your business. So when you think about a free-flying space station, you have all these companies now attempting to build free-flying space stations, or attached to the ISS. How do you perceive the market opportunity for that? And yeah, maybe let's start there. What do you think of the market opportunity for free-flying? Obviously, your belief is that it's big, right? Hence why Gravitics could be a big business. But I'm kind of curious how you think about that.
The excitement around this, first, for any listener that doesn't know, ISS is retiring near the end of this decade. Similar to what we've done with cargo and now with people, NASA is moving towards let me buy from commercial sources, services or products. And the CLD program is enabling a series of commercial stations coming online to service NASA's needs. Some international players will join NASA in kind of riding along and paying on a per astronaut basis to be on commercial space stations. We're seeing some interest in international, different nation states wanting to launch their own. Japan has recently expressed some interest. UK has expressed some interest. We'll see where some of that goes. Some of those may decide they want to plug into ecosystems that NASA CLD competitors are offering. So there's an ongoing NASA need. So we're going to have billions flowing into this regardless. The question is, how do we build on top of those billions commercial interest? I mentioned to you a little bit ago kind of that app store analogy. We are right at the cusp of an incredible future, but it's important to note that a lot of that opportunity is still right at the beginning. Imagine buying that first iPhone and finding that the app store was relatively empty. How challenging it would be to justify that large cost and to say, yes, I can clearly see my future for how I'm going to use this device to add productivity or all the other things that we use our phones for today. We are there right now in the industry. Those that are making bets in this space are saying that the work that's being done in manufacturing with crystal growth, with pharma production of crazy body parts, knee meniscuses and heart tissue, some of the really exciting announcements just recently, fiber optic growth of Z-band cables. There's just a variety of things, which is going to be that, the next Uber that changes the game. I think there's still some debate, and it might be fun to do one of these podcasts where everybody takes a different position on which is going to be that killer first app. But that's what these groups are fighting for. What's going to be the products that can be produced there that make humanity better off on the ground?
Do you have a strong opinion on what you think that sort of initial killer app could be? Because I ask because sort of taking the I think there's I've heard a lot of investor pushback around this concept of these various markets and how big could they truly be, and that they're in general pretty speculative. Z-band was one market, everyone talked about it, and then I know there's Varda was originally pursuing Z-band as a market. Now they're doing biopharma, and there's sort of these adjustments that have taken place. There's no question that there's been a whole host of ISS-led experiments that have taken place. And of course, the biggest challenge historically has been there's been no commercial off-ramp off of the ISS to really take advantage of the work that's being done. But I'm kind of curious, if there is a market that you're particularly thinking about or spending some time on, or as you build your modules, you have this kind of use case in mind, maybe talk a little bit about that.
Yeah, I think some of it will be behind proprietary doors that I'm not able to go into a lot of detail, but again, being on the infrastructure side is kind of fun because we get to be early in conversations where someone says, here's my cool idea. Can I put it inside of one of your Lego bricks that you take up there and plug into an existing space station? And the reason that we're being a part of a lot of these conversations is because there are questions as to, I don't know who the winners are going to be yet. And so there hasn't been this future probably consolidation, or at least an announcement that regardless of what NASA decides for who they're going to work with, the space station is still moving forward. People come to us and say, could you build us a module that's compatible with any of these stations so that my business can move forward? We've had groups come that are excited about silicon carbide chips, groups excited about farming opportunities, groups excited about the ability to bring heavy amounts of equipment up there for a variety of applications. Kind of can't really share the details of which that really haven't been possible up until now. So part of the challenge is an identification of the killer app. And notice that I don't have that magic to say it's going to be this one. But what is about to happen with the ability to bring heavier things up in one launch, so think Starship and New Glenn and some of this kind of potential future, as well as larger volumes, so more mass, more volume in a single launch. Some of the modules behind me at 8 meters, which is what these are, give you 3 to 4 times the volume. And, if you think like a Falcon 9 can bring up maybe 15, 16,000 kilograms, and we're talking, 50, even in the early generation, 50,000 plus from a Starship, climbing significantly above that as the later generations go. We are going to be able to do some things that we've never been able to do before. And so whether we find that killer app immediately and some of the early plugins to any of these stations from these commercial groups that are coming to me, are them in their Gen 1 form ready to go? Or as you see several of these groups doing, we mature into that by finding more commercial friendly ways to help the rest of the world experiment in space, but do so now. So for example, there you look at like Pillbox, a product that Redwire uses. Eli Lilly has been working with them to be able to fly experiments on the International Space Station today. How do we make it very easy to onboard existing R&D budgets for the benefit of humanity? How do we on-ramp new nations that have never had a role in space before to be able to get their astronauts up there? We have several groups exploring that. So we could see that being the pathway there, that we find smarter and easier ways to do work in space, happening at the same time that it is cheaper to bring up more volume and more mass than we've ever done before, while we continue to find better and smarter ways to be able to finish the pre-commercialization phase so that those killer apps develop on the other side.
Yeah. No, that makes sense. At some point, I do want to talk to you about silicon carbide, because in my banking days, there was a company in Germany that we spent a long time on doing diligence that we ended up investing in, and they built the furnaces that are used in the production of silicon carbide chips. Anyway, so total
absolutely, we can nerd
tangent
out about it. There's some fun stuff going on. Absolutely,
total tangent. I want to spend a little bit of time on a comment you made around the launch vehicle market, what that's going to look like, and what that's going to do for the ability to send large amounts of mass into space. I'm curious, and this is a theme we've touched on in previous episodes about this idea of like how these large mega launch vehicles are going to change the way we think about design in aerospace and the concept of mass constraints, which will be fewer and fewer over time. Has that affected your design decisions? Like, are you thinking ahead and thinking, okay, well, Falcon 9, Falcon Heavy today, Starship in the future, hey, maybe we don't need this super high, super expensive piece of equipment, because we can now use this instead, because we can make it a little heavier, but that's okay because the way we launch things are going to change. I'm kind of curious if that's been something that's been part of your design decisions as you've been building these modules.
It definitely has. I think back on the engineers that I'm standing on the shoulders of that put us on the moon, that built the ISS, and the mass constraints they had to live with and the incredible workarounds they had to do in order to get anything up to space to be able to use it. That comes on the structure side. And so any of your listeners that aren't familiar with IsoGrid, that's definitely worth watching some videos on how they It kind of looks like a waffle when you're done. The amount of material that they auger out to be able to lightweight this material is incredible, because they've analyzed ahead of time exactly the amount of loads that material needs to take, and no more. Some minor amount of safety margin, just enough to say, I'm good to risk it. Let's go. And we've done some incredible things in space, but robust is not one of them. Moving towards a mass agnostic future helps on so many levels. How we build the craft, but think about this. It's also how we use space. Right now, this is going to be an oversimplification, but I have cool thing I want to do in space. I get in line for the ISS. 2 years later in the US, maybe 5 or 7 years later, if you're in Europe, you go up. You do cool experiments. You then come back down, either by sending your bits or the little results of the experiment, to a well-stocked lab on the ground. You find out that cool progress was made. You iterate. You get back in line. Maybe you get to skip the line a little bit, but still you wait, and then you go back up and do it again. That idea of getting to the app store becomes very challenging if that is the cycle I have to go through. You have to be very dedicated to be convinced there's a commercial application at the end for you to do that. And that's not a timeline that works for most R&D managers from any existing company. And so largely it gets skipped as a potential. Now imagine this. What if we take that well-stocked lab and it can actually get launched now? Now, with that much mass that can go in one of our modules, we can lift very, very heavy things with New Glenn, with Starship. And now if that well-stocked lab is a part of your space station setup, now you go up and you do many, many iterations over a weekend. And so that by the time you're coming back down, you're ready for commercialization. And we've shortened that valley of death of, I did a cool thing on the ISS, but I still am not ready to actually go raise money and go do my own company. The game totally changes with that. So it's going to be fun to see how some of these space stations develop, helping groups with that last step towards commercialization by shortening the cycle in a way the ISS never could. Not because there were deficiencies in the ISS itself, but because it was limited by the technology of the day that these new companies are not going to be limited by. Yes, it's new capability, new mass, new volume, but it's what that does to the commercial industry that's going to be so exciting.
So let's talk really quickly about competition. Because you are a builder of the modules themselves, in a way, the companies that I would normally have suggested as competitors are not necessarily competitors, but they're customers or potential customers. Now, one way to think about it is I'm not going to point any fingers at anyone, but there could be companies that are like, well, I'm going to just do this myself. Why do I want to outsource this? This is like my core, or maybe this is my competitive advantage. Talk a little bit about how you need to turn a potential competitor into a customer. Maybe talk a little bit about that journey, and then talk a little bit about what you're doing differently from like existing providers like Thales, Alenia, that have built modules on the ISS before, that have that heritage, and likely want to continue doing that business. So yeah, maybe talk about those two things.
So let's first make it generic, and then we'll talk about what we're doing here. A generic playbook. I'm new company. I have cool new capability on paper, or maybe some nice lab tests. Hey, this is better than anything else in the industry. Okay, but the industry doesn't trust that this thing will perform. How do I reduce that risk? I might fly it in space. Gravitics is flying later this year, components up to the ISS. I lock in an early customer that's going to be willing to pathfind with us and serve as that thing that I get to point back to and say, see, Sally's using this in space, so everybody else should too. Axiom is that for us. And then as we get past that, you start seeing greater and greater industry acceptance of saying, I could go build a new one, but Colin's got one just sitting here. And why not take advantage of that? Because it speeds us up so much. That's the whole reason to use partners. You don't have to do that CapEx. You don't have to take that time in order to go build it on your own. Our modules are designed to fly from Stoke to Starship. So from as far down as 3 meters, as far up as 8 meters in diameter. with a fair amount of customizations. Behind me, you see some examples of windows embedded in it. We can offer you berthing or docking or a variety of different things on the end. We use wrap solar, but with the ability for rollable. So a lot of capability that can be customized for you over time. Walk before we run, grow confidence through execution. That'll be how we win more of the industry over as we go. And we're so thrilled to have this early partnership with Axiom to be able to take some of those early steps.
And then maybe talk your approach versus existing providers.
Yep. That flexibility we're maintaining in diameters gives us launch vehicle flexibility. If there's issues with a particular launch vehicle, or if you're wanting to achieve some of the uniquenesses that a launch vehicle might offer you, say, low launch costs that Stoke might be able to offer, incredibly high volumes that some of the larger vehicles may be able to offer, we can provide you that capability without you needing to maintain all of the CapEx to be able to build it in-house. And so what's going to happen early on is if some have already taken those steps to lock in a capability or have already spent that money to be able to do some of those early units, then you'll start seeing our technology get added to theirs. Again, it's like Lego bricks. We'll help them scale over time. A few of them that we're in conversations with that we catch early enough, we hope to be able to even change that architecture from the very beginning so that when you start seeing these phase 2 CLD offerings, we hope to see kind of a whole industry start using some of those renders start getting updated with us on the team. So we hope to be able to announce some of that soon.
Yeah, so it's interesting because, you know, in a way, if you talk to the institutional investor and you talk space station, the first thing they think is CapEx. This company needs $1 billion. That company needs $1 billion. This company needs $1 billion. Okay, so we have all these companies. Some of them are well funded. Some of them are going after big markets. But in a way, it's like if you get everyone to say, "Well, I'm just going to use your Gravitics module, and I'm going to focus on the operational side and like the business side," then it's like you've kind of immediately reduced the overall CapEx need of the entire industry. I don't know if you agree with that, but I'm also more just curious, like, there's a lot of station providers out there. Your business is reliant on them being successful. Like, I'm asking a question that's somewhat rhetorical because I feel like I know the answer that you're going to give, but like, the market in your mind is large enough to sustain all these station providers, and do you believe that there's enough capital out there on the investor side to sustain all these businesses? Like, maybe talk a little bit about that dynamic.
Yeah, sounds good. So I'll start small and then I'll kind of speak about the industry. So at the micro level, what we help a company be able to do is to say one of two things. I can save you time or I can save you money. Hopefully it's both. You're wanting to explore maybe a new size. Maybe you've already invested in the 4-meter size, the size that the ISS is built to, the size that we're building for Axiom. And you're ready to start exploring what you hope your end architecture might be, 6 or 8 meters, something larger. And you can say, okay, Gravitics, can you build my first 6-meter or 8-meter module? You'll save me 2-3 years of development time. I need to stay here at the 4-meter size. But I'd love to use you going forward. And I already have a customer need for this next module. So we're adding capability at the time that revenue is showing up. So there is far less, hey, Mr. Investor, bet on me, and some distant time in the future, there's going to be a payoff. No. This is a particular customer that needs a module now and is ready to pay now. Gravitics provide that module, and we will help you scale profitably from the beginning. So at the micro level, that's really the pitch that we're making to groups, better tying revenue with the time of the CapEx expenditure and allowing us to hold a lot of that on our balance sheet. And so largely this is customer funded as they move forward. That probably won't be exclusive, but that's the hope, is that for a lot of that, for different companies on the operations side, that they're operating that way. Okay, so now to your industry question. What I see happening is consolidation at some point. It will make sense that it either happens right after the CLD bid or right before. I could see scenarios where going into the next round of NASA funding, Colin and Mo team up and we have a better space station offering, because what used to be 2 offerings, now powerhouse, we get to offer 1. I could also see scenarios where on the other side, those not chosen or, something along those lines either join forces or maybe even bow out, and we see further thinning as a result of who the winners are from NASA. Separate from that, or in parallel, as far as time goes, you're going to see on-ramping additional players that are either coming, I would say the ones that are being reliable are going to be coming from nation states. So I mentioned Japan and the UK before. Who else may want to play? There's optionality here. They could play by joining on and having a module attached to one of those stations, in which case, again, we'd love to build it for them. Or they, for national pride or other reasons, may decide that they want to operate an entirely independent space station and would follow many of these same steps. But now, in addition to China having a station and several U.S. stations, we now might have, Mitsui or someone else providing a full station just for one of these nation states.
So is your long-term vision, I was going to ask at the end, but this is a good time to ask, which is like, do you think that, so the ISS is a treaty of a number of different a number of different countries, right? With the US being the primary financial contributor. In the same way that, like, people say, oh, the launch market's super crowded. And I would say, and I always usually have to say, like, it is in certain respects, especially when you look at the US players. But if you're looking at launch players globally, most of the major nations, G5, G7 nations, and beyond, want their own launch capability for national security purposes. Like, so yes, there's a SpaceX out there, but at the end of the day, like the UK and Europe want their own capability. They don't want to rely on an American business. Do you see a similar dynamic play out in this kind of space station business, where you'll see situations where, like, countries themselves are going to want their own capability, and just because there is an Axiom or a Voyager or Vasta or whoever, like they'll still want their own capability?
Yeah, I think it's going to be interesting to watch. You already see it with what Axiom has done in catering to those new nations that want to expand their space capability. And it's exciting to watch that, right? They probably don't start with owning their own space station. They probably start with some experiments that are brought up, expand that to their astronauts flying on an Axiom station. We could see expansion of nation modules attached to one of these commercial providers, with then that extending to, I don't want my own module attached to VAST. I want my own module attached to my own station, and I want to run the whole show. You definitely see Starlab kind of preaching that potential of saying, you get a station and you get a station and you get a station, and I can put them up all in one go on a Starship. So there's definitely that potential. We definitely see from some the nations I've mentioned already an excitement around that. Add India in and their excitement around that. We could easily see that being the natural progression of a new nation wanting to expand into space, and for the first time having some commercial opportunities of ways to walk before they run. Now, whether they stop there and they're comfortable continuing to operate their own module on a U.S. company's station that they can just lock the door on, and this is India's own module, and they're comfortable with that being the end of it, or whether they want to insist on having a full capability, then you get into national interest versus budgets. What can they actually maintain? They can say one thing, but they have to pay for it. So it'll be interesting to see how the industry develops in that way.
Got it. No, super interesting. All right, let's talk StarMax. Okay. Tell us a little bit about, you've already, we've teased it out in a lot of different ways, but give us the overview of StarMax, the progress, key milestones you're focusing on. Let's start there.
Okay. So, building blocks for space, pressurized, unpressurized, variety of diameters and flexibility to fly then on from Stoke to Starship, a variety of different launch vehicles, different customizations possible, as I mentioned, on how we can modify your particular module for your needs, built with an industrial mindset for how do I build many of these at low cost, pass those savings on to end users. How do I build for scale? So how do I build so that these modules can be connected in space and be able to help stations grow over time? Those were some of the underlying key themes we wanted to be able to achieve. Now, I mentioned before the idea that the module itself is, yes, a pressurized space of a variety of volume. We developed our own thrusters. Those thrusters we fire right outside that door right there. And all the technologies, although we do a lot of work that is only robots on the inside, we designed our technical systems to be maybe human compatible, might be a good way to think about them. So we're using propellants that gaseous oxygen, gaseous methane, these are things that humans can be around. And by using a gaseous form of them, these tanks are not going to be under such extreme pressure that they're going to hurt a human. And, at least it reduces that risk, kind of a thing. Additionally, our battery technology is safe around humans. You can't use lithium ion very easily in space. That same fire that happens under the Christmas tree at home when the scooter explodes on Christmas morning is the same fire that can happen in space. And you're seeing some interesting, challenging solutioning being done right now with battery technologies in space that we're hoping with our battery technology to be able to make far easier and far safer for the whole industry. So these are the kind of choices that we went through as we're kind of wrestling with how do we make a human compatible space module that is ready for scale for, as I mentioned, for everyone.
How do you think about insourcing? I think I just made up that word versus outsourcing.
Right. Vertical stack versus going horizontal and having partners. So it's interesting because what am I saying? I'm asking the industry to not vertically integrate. Come work with trusted partners like Gravitics to be able to grow your station. And I would be a hypocrite if I then said, we don't have partners ourselves, we're going vertical stack, right? The industry needs to move away from that exclusive thinking. I get why it was done in the past. We had to increase our reliability as an industry. There was so much that needed to be done to be able to trust supply chains in ways that other industries do. It just wasn't mature enough. And I see why SpaceX has done so much of the vertical integration. We still do a lot of stuff in-house. As I mentioned, if there really wasn't a solution externally we could use, we looked in-house. But we've also, we're using Empower for our solar cells, and there's a variety of other partners we're using. So if you've got the right technology offered to the industry, we're happy to talk. And very comfortable with saying, how can we onboard your tech into what we're doing moving forward?
Can we talk a little bit about scale and the manufacturing challenge, right? Because there's one iteration of like, let's get product, MVP product or product number one to built, and then it's like, let's do this. We need to do this 10 times. If Europe comes to you next week and it's like, Colin, we need 10 of these. Like, what are you gonna like? Are you ready for that? Like, tell us a little bit about how you planning on scaling manufacturing.
I had a boss once that called that winner's problems, and I would love to have that challenge for scale. But let's talk about two kinds of scale. One is going to be at the 4-meter size. That is a manufacturing question. How many simultaneous runs? How quickly can we work through? Again, we're being careful here. One of the lessons is we're not moving towards automation, right? We're trying to get the manufacturing process repeatable, and then we can start talking about how do we automate. And there's lots of lessons learned that SpaceX has, I think, helped the whole industry to kind of understand of the right timing of when to experiment and when to be comfortable with the crazy new idea to make it better, and when to wait before you start deciding, okay, I think I've got the process down. How can I now make this, was it the 300th Raptor that showed out of its Starbase this week or whatever? So that kind of lessons learned we're definitely paying attention to. So we'd love that problem. And when Europe's ready, please forward their number to me and let's build them 10. The second problem is with size. As soon as we start talking 6 and 8 meter, those are not easily roadable. Perhaps at 6, there's one plane that you can use to be able to fly it to the launch pad. But there again, you need to have some way to be able to receive a facility at the Cape, basically, to be able to do that. So we're already wrestling with that question in conversations with groups at the Cape to be able to set up a facility designed for 6 and 8 meters. And just think through those logistics. Almost for sure, 6 and 8 meters is going to be outfitted at the launch site. And so even if you've got your cool, we were talking about silicon carbide chip that we're going to nerd about later. Let's say you have a process for silicon carbide chip manufacturing. Maybe I've been helping you from the beginning on how to take your equipment that's currently in a lab and make it fit in one of these huge modules behind me. But just the same, that's being manufactured in one location. I'm manufacturing these at our facility at the Cape. You're bringing your equipment in. We're making that all that integration work is going to happen right there where we roll up the massive door and then take the biggest go-kart in the world down to the launch site and up it goes. So the challenges around manufacturing is that we didn't design our roads to be able to handle this scale of equipment. So the fun challenge of such new launch capabilities is that to truly fill those fairings is going to mean we absolutely are changing how we think about where we manufacture. And we actually are going to have to invite our partners to our facility to do that integration because it can't happen anywhere else. It's just too large.
Let's talk about testing because your modules haven't been to space yet. So how are you thinking about testing on the ground and developing a certain degree of confidence that when you get it up into space, it's not going to collapse under or break apart or
right. So
age-old challenges we see in sci-fi movies.
Absolutely. Well, first off, on a safety perspective, this is the only way my daughter's going to space. Our modules have so much more safety margin built into them because we can, right? The new generation of build for scale also means you can build for safety built in. I'm not hollowing out these materials to get them as thin as they possibly can be. So it does raise a set of questions. Right now, our assumption is that we test everything the same way we always did. Even if the old world said, I'm going to make this like tissue paper thin and fly it to space. And I'm saying, what are you talking about? I have a 1/4 inch of aluminum here or whatever. The difference doesn't matter in the early days. We're just going to pass all of those tests. But it will be fun in the future when people start going, oh, this test may not mean the same thing under the new world order that it did in the past. But that's going to be a journey. Let me describe a little bit of that journey. A year ago, we built 8-meter modules. We built the door here knowing that it would never leave our facility. And we took it out and pressure tested it to 2x what the ISS is at today. Didn't burst. So incredible amount of hardware-rich early work, proving our manufacturing approach, proving we can really build this way and at this size, right? Because we've never asked that question before. Can we really build at 8 meters? Yes, we can. We're working now. We've got a Space Act agreement with NASA, and we're asking hard questions collectively. We're saying, okay, so what do we do when at 6 and 8 meters, we've exceeded the size of some of the testing equipment that exists in the world? Or the equipment exists at Marshall, but I can't get a module to Marshall at 6 or 8 meters and then get it back to the Cape or wherever we're going to launch from. So the work we're doing with NASA is specifically to explore that trade space. How do we build robust, safe modules for the future? And how can we do kind of the thought leadership work between NASA and Gravitics to recommend a series of solutions for how we can test safely, how we can ensure that they are going to be as reliable as my daughter needs them to be, and yet recognizes the challenges and the opportunity that 6 and 8 meters really presents.
What are the technical challenges that keep you up at night? Where you're like, hey, this is going to be hard?
A lot of it is going to be around the brains, right? There's several groups that are working on exciting technology to make RPO and flight software as generic as loading an operating system. And I can't wait for that day. And we've got some groups where we're talking to now that think that that day is very close. I can't wait until it becomes as generic as the number of thruster vendors that have ballooned over the last 2 years. That is a problem that needs solving and needs solving in a way that docking and berthing events become as generic and boring as landing first stages on barges has become. It's one of the conversations that, topics you and I were talking about earlier was moving from pre-commercialization to commercialization. Well, some of that is an operations problem, right? When external work around a space station takes days and weeks, maybe months to prepare, when a docking event is such a significant thing that we try to limit the number of times that we have that's those are going to be those things that hold us back. If we're really going to move into true utilization, we're going to need to find solutions where those activities are more ubiquitous and are happening at a far greater cadence.
Let's talk commercial and government traction so far, to the extent you can share. Obviously, there's the Axiom contract out there, but how's that going? How are the discussions going so far?
Yeah, so I think the part that surprised us, but probably shouldn't have, is when somebody brings you a pile of Lego bricks, it doesn't take too long for the child sitting at the table to make some pretty cool things that maybe you hadn't considered when you created the bricks in the first place. That is happening now, as we're finding groups coming to us and say, well, that's cool, but could you, if you went unpressurized but just had a hinged door, could you make a garage? I could do a lot of things in an unpressurized garage. And that'd be really nice. Could you still make it so it could attach to a space station? Could you make it and act as a free flyer? Those kind of things have been really fun to see groups come to us. The DoD interest is significant. So they are, we're under contract with them, but for both the battery technology that we're developing, as well as work on orbit spacecraft carriers. The idea of being able to pre-position assets not at the launch pad, ready to go in an emergency, but let's solve past the launch problem, store those in orbit, and give you a lot of that same capability. I love the Firefly guys. They were able to do tactically responsive launch, 30, 35, 40 hours kind of a thing, kind of cradle to grave. But there were still a lot of things prepped for them to make it all work great. We knew we were going to have a nice, clear weekend, so weather wasn't going to be a problem. We already knew what we were going to launch. We had it all pre-positioned and ready, sitting there. And you had a rocket on the pad, on standby. What we're trying to solve is that next piece to say, that's important. We should keep doing that. But tactically responsive launch is one piece of the puzzle. Tactically responsive space allows those very same assets already in orbit. Now I can be in any orbit in 3 to 12 hours in cislunar space. There's a powerful message there, and our modules provide that core carrier capability to be able to hold those assets until they're needed in orbit. So that's just one example of I hadn't considered that when we first started the company, but they're helping to pull us into happy to solve those space infrastructure problems for the U.S. government.
So that's an interesting concept. So are you kind of saying and I hadn't thought about that. So I'm the government. I have an asset. I'm going to put it into one of your, Gravitics carrier, right, version. It goes up to space in that carrier, and then it's hanging out in space. And one day, surprise, surprise, this is what we have. From a military perspective, right? From a deterrence perspective, hey, we have these carriers up in space, but it's hard. The adversary doesn't know what's in there.
Well, it's interesting. We can definitely have that conversation, and there is all the benefits you described, but also think space search and rescue. Imagine being able, an Orion that gets somehow stranded, kind of new Apollo 13 style between here and the moon. What can we pre-position that can go out to them? What about an asteroid like Apophis coming in 2028, 2029? But instead, one of these near asteroids that we didn't know until a very short window of time before it buzzes between the moon and the Earth. If we have the right capability, can we launch a capability out to go quickly rendezvous with that and kind of, continue to study it as it leads? So yes, there's military applications, but pre-positioning assets in orbit give us a lot of exciting opportunity for other applications besides just military ones. So there's civil applications as well.
No, that's super interesting. Give us the sort of long-term view. What is, I know that, artificial gravity, we talked about it at the very beginning of the show. What is that? How far away before, Colin, you and team are sending up something into space that is, creating artificial gravity?
It wouldn't surprise me if somewhere over the next 5 years we're doing, experiments that allow us to take some assets in orbit and just spin them up just to be able to start to get that experience. There's so much that we need to understand. How do we damp out perturbations? How do we do appropriate spin up and spin down? All these kind of challenges. But the modules themselves are designed to be able to support that activity when the time is right. So excited about that future still. But again, with the lens of finding those partners that are ready to operate those stations. And so we'll continue to provide the space infrastructure needed between here and the moon and beyond. Excited about how that the lunar needs continue to develop along those same lines we were discussing logistics, discussing real estate, discussing power. Those verticals are still very strong for us and will continue to be. How the particular applications change between here and the moon, between zero G and spun gravity, and then beyond cislunar space out to a solar system. That canoe that's currently circling the island really does need to start looking at deeper water, and it's going to be exciting to be a part of the real estate play as we start expanding out.
How many years away are we from Elysium?
My artists have already taken our modules and built some really fun stuff. So it's definitely fun to look at that. We are still probably a few years to go before.
All right. My final question, Colin, is the new question I've been asking people, which is who's going to play you in the TV movie or the future movie about Gravitics? The biopic. Who's playing Colin?
Somebody willing to shave their head. So
maybe Jason Statham, and we do like an action flick.
I'll take it. Yes, absolutely. Some terrorist group or something, and he's hiding out in all the modules or something. I don't know. We can get the facility to be able to use for it. That's fun.
Super cool, Colin. I love what you guys are doing and building, and I'm very excited to see it all develop. And now, honestly, this has actually been a great learning experience for me. There's a lot about your business I didn't know, but it makes a ton of sense, and very excited to see how Gravitics builds in the future. So thanks for being with us. Really appreciate it.
Mo, thank you so much for having us. Appreciate it.
Until next time.